Have you ever just looked at a game you're playing and thought, how in the world did they make this? Well, today we're going to go on a little quest to find out. We're going to start with nothing, just a blank screen, and by the end, you'll have the basic tools to build your very first game. So let's just dive right in.
It's a huge question, right? Kind of feels impossible. You're probably picturing these massive open worlds, really complex characters, amazing graphics. But what if I told you the whole journey, it starts somewhere much, much smaller?
Okay, so take a look at these two things. On the left, yeah, that's a Nintendo Switch. It's a powerhouse, a total masterpiece of modern gaming. But on the right, you see that tiny little circuit board? That's called a microbit. And believe it or not, the core ideas that make the Switch work, you can learn them right here, on this little guy.
All right, so every quest needs a purpose, and every builder needs their favorite tool. For our little quest today, our tool is going to be the microbit. And our purpose? To figure out how to take an idea from your head and bring it to life with code.
You know, deep down inside the Switch, inside your phone, and inside our little microbit, there's this one crucial thing, a microprocessor. You can just think of it as the brain. It does three simple things. It takes in information, we call that input. It thinks about that info, that's the process, and then it does something, and that's the output. That's it. Input, process, output.
So how does our microbit's brain sense the world around it? Well, its inputs are kind of like its senses. It's got an A button and a B button you can press. It even has something called an accelerometer, which means it knows when you tilt it or shake it around. And how does it act? Through its outputs. It has this little grid of 25 LED lights to show pictures and a tiny buzzer to make sounds. These are the pieces we get to play with. Okay, we've got our tool. Now it's time to learn the first magic spell of coding. And that's teaching our tool how to make a decision all by itself. This is the moment a simple device starts to feel, well, smart. This right here is the secret. It's the core logic behind almost every program ever made. It's just a rule. If you press the A button, then your character jumps. If the enemy sees you, then it attacks. Everything, and I mean everything, really just boils down to this simple if-then idea. Now, before developers write a single line of real code, they usually make a plan. And that plan is called pseudocode. It's really just plain English that lays out the logic. So for this little compass program, the plan is simple. If the microbit is tilted left, then show an arrow pointing left. See? It's just the blueprint. And here's the magic trick. You can see how that simple English plan turns directly into actual code. See that line that starts with if? That's our plan. It's just written in a language called MicroPython, which is something the computer can actually understand. The logic is one-to-one. And the fancy technical name for what we just did? It's called a conditional statement. All that means is that the code checks if something is true or false, like, hey, was the device really tilted left? And if the answer is true, it runs the next bit of instructions. This is how your program makes choices. Okay, so our device can react. It can make a simple choice. But let's be honest, that's not a very exciting game yet. It's time to level up. We need to add some new skills to our arsenal to make things truly interesting and fun. I mean, a game that does the exact same thing every single time. That gets boring pretty fast, doesn't it? We need a way to remember things, like a score. We need to handle lists of items, and we definitely want to avoid typing the same commands over and over. So how do we do all that? We add two brand new tools to our toolkit. First up is something called a variable. The easiest way to think about it is just as a labeled box. You can put one piece of information in it, like the player's current score. And second, we have an array. This is more like a big treasure chest. You can stuff it full of all kinds of items, like all the different enemies or power-ups in a level. And this is a perfect example of that treasure chest, the array, in action. The plan here is for a Guess the Animal game. You can see there's an array called images that's holding all the different animal pictures. This is so cool because it means the program can just reach into its chest, pull out a random animal, and show it to the player. It makes the game unpredictable. All right, now let's talk about being efficient. Let's say you want your program to flash a light 3 times.
You could write the command out 3 separate times, like you see on the left. I mean, it works, but it's messy and honestly kind of clunky. Or you could use a loop, like you see on the right. It does the exact same thing, but it's clean, it's short, and it's elegant. You're letting the computer do the boring, repetitive work for you.
The official term for this is a count-controlled loop. You just tell it, hey, do this action X number of times, and it handles it. This is way more than just tidy code. It's incredibly powerful. You want to fire 100 lasers instead of 3? You don't write 97 new lines of code. Nope, you just change one single number inside your loop. So, you've written your code, you've got your variables storing data, your conditionals making decisions, and your loops doing the heavy lifting. Your game is really starting to come together. But you're not done yet. Now you have to face the final boss of development, testing.
This sounds totally backward, I know, but it is maybe the most important step of all. A really great developer doesn't just check if their code works, they actively try to find ways to make it fail. Every single bug you hunt down and fix just makes your game that much stronger and better for the people who will play it.
So, how do you actually do this? You create a test plan with 2 kinds of data. First, you use normal data. These are the inputs you expect the user to give you. For our compass, that means tilting the device left and right. But then you use invalid data. These are the things a user might do that you didn't plan for, like what if they just start shaking it violently or pressing buttons. And this is what a professional test plan actually looks like. You can see here there are tests for the normal stuff. Test, tilt left. Expected outcome, arrow left. But just as important are the tests for the weird stuff, the invalid data. Test, press button A. Expected outcome, no change. We have to make sure our program doesn't crash or act weird when the user does something unexpected. So let's just zoom out for a second. We've gone from a totally blank screen to a fully planned and tested program. Let's really look at what we've covered, because right now, in this moment, you actually understand the core logic of what it means to be a developer. And what's so amazing is that these 5 concepts, variables for saving information, conditionals for making choices, arrays for holding lists, loops for repeating things, and testing to make it all solid, this isn't just for a little microbit, this is it. These are the fundamental building blocks of basically every video game you have ever played, from Pong to the latest blockbuster. Just look at this. This is the complete set of rules for a what am I guessing game. A little while ago, this might have looked like complete nonsense. But now, you can see it, can't you? It needs to pick a random item. Hey, that's an array and a variable. It needs to check the player's guess. That's a conditional statement. It all makes sense. You now have the knowledge to build this from scratch.
You've done it. You've completed the first coder's quest. You get the logic. You have the tools. The only thing limiting you now is your own imagination. So I'll leave you with this question. With these building blocks, what's the first simple game that you would build? Thanks for watching.